Hello everyone, welcome to another session of Small Talk. First of all, I would like to apologize a bit. I was planned to do this talk last Friday, but I wasn't available. But hopefully from today onwards, we can continue this series and without a breakup. So today's session is about how to write a good API. So essentially, in this session, the as the first thing, I'm just going to go through what are APIs, like a general description of that. So essentially, what I want to focus about is like API. When you say the term API, it could mean different things to different people, different developers or different users could see different things in that. For instance, if you talk about an API with someone who writes web services, they would think of it as a service, a REST service maybe, which is exposed to the web. And for someone, for instance, who works with backend libraries, our API is a library API. Think about maybe Log4j, the API which it has. And it could even mean things like basic OS level hooks that some people might use in order to extend the operating system functionality. So, I mean, an API generally could be like any of these things, like any of these levels, and it could be anything in between. So a general definition here I got here like is a collection of software protocols that a developer can access through a contract or an agreement. So that covers everything from REST APIs to software libraries to OS level hooks or any of those. So when going through that, so the points that I'm going to talk about today would be general terms, general points for all of these APIs. So first of all, I would like to show you an example of an API. Now this is the API of the Linux plugin authentication module. So essentially, it's like I'm showing this because the SWAT team used this recently to plug in IDM for I think on the POS devices. So this API was written I think in the late 90s. So it's essentially a C header file. Now I wanted to show this for two reasons. One, to show that there can be APIs like this written in C or any like basic languages like that, and to show some of the bad things that are there in this API. I mean, when we compare this to modern day standard, it's quite horrible in the sense. But I mean, this is supposed to be called by the Linux, by the OS. So like external developers won't call it. But still, if you look at some of the things like the method names, the parameters they take, and some of the language restrictions of using C has affected this API. But nonetheless, it is an API, it's widely used as well. So next, I'm going to go through some of the attributes of writing a good API. So the first two things that I want to look at are simplicity and the fact that it should provide useful abstractions. So these two things go in hand. If you think about simplicity, be it a REST API or like a library API, things like method names, the amount of parameters, the query parameters that you have, the format that you return your data in, those things need to be simple. And like to make things simple, it's really difficult, like when you have a complicated backend stuff, when you're working with the functionality that you're like exposing through the API is complicated. And the usage of abstractions goes with that as well. So essentially, so I'm just going to look at an example here and to explain those two things first. So this example is from, I didn't write this, so this is a utility class from the Apache Commons framework in the Maths module transform. This is a class for fast Fourier transformations. So essentially, if you don't know what that is, you don't have to worry about it. But essentially, it's about converting a signal, like a set of data points in a time domain towards a frequency domain, or the other way around, from the frequency domain to a time domain. Like, this class, and the class itself, the implementation is about 700 lines. There are some, like if you look at the implementation, there are complex logics there. But when you look at the interface, it's quite simple. Like the methods here are like transform, transform, transform in place, And the way you initialize it again is quite simple. And things like the naming, the method names, the names of the parameters, the number of parameters even, I mean, they are quite simple and easy to understand. And the abstraction this class, this utility provides is this functionality of transformation. And as you can see, the class name is fast Fourier transform, and the methods are not processed, they are not managed. The methods are transformed. Like it provides a clean action, like a it's very natural. So that's one thing that I want to explain on these 2 points of simplicity and the abstraction being the transform function. So the next thing which I'm going to talk about is a very important point, which is discoverability. Now, discoverability in this sense, it's not like if it's like available in the web or like when you try to find it. Discoverability in the sense like when you're trying to use an API, most developers won't read through all of the documentation before you start using it. Usually what people would do is like maybe glance through the documentation, maybe look at some of the examples of using it and start using it right then and there. I mean, no one's ever going to look at all of the documentation that you've written. So the API that you provide needs to be like the developers need to be able to discover it, because that's how like you discover the APIs. So in this sense, this is a very good API. It has some good points. For instance, again, the method names and so there are 3 overloads of this transform method, and there's a transform in place. Now, the transform takes in like arrays of complex objects or complex, these are numbers, and returns complex numbers. And there's a transform in place method. And as the name suggests, it doesn't return anything. It takes a 2D array and transform it in place. So things like that. And another thing is the usage of enums. Now, as I said, the fast Fourier transformation can be done in 2 directions, from the time space into a frequency space, and backwards as well. So that, I mean, they could have had like 2 methods to support that, but they didn't. They had a enum of transform type, which has 2 values, forward and backward. So essentially, so this could have been implemented maybe like an integer or 0, 1, a bool, like forward true or something, but they didn't. They did it through this, which makes it accessible and readable. Like, like when you try to discover this, and when you look at this enum, you can clearly see how it's been used. Like to talk about all of this, I didn't go through the documentation at all. I just tried to implement it. So that's how like people. So again, this normalization is another enum like that, which like limits the chances that you'll make a mistake when you're trying to use this API. Things like that, like enums, the usage of enums, like a very basic thing at language level. You don't have to even talk about it like for developers. But like when you actually go to expose something like this, it's really important to think about it less like the user's point of view. So the next thing is testability. Again, testability in this sense has 2 things. Like as the developer of the API, you should be able to test it, and whoever tries to use it might be able to run a perf test on it or test it like that. So again, going to this example, so whenever you want to initialize this, you only have to pass an enum, which is configuration. You don't have to like mock 10 things and put that in just to test it, which makes this API very testable. Like you can simply initialize a few variables and test it out, which is again very important. Like if this thing, like if one of these methods had a call out to say a singleton, like a static instance, and to say email service or web service or a file writing service, things like that, then it would have been very difficult to test that in a unit test level or else. So in the internal implementation, it's really critical to like make it testable. And another thing is consistency and being symmetrical. So for instance, if you take something like a REST API maybe, like in the REST API, the query parameters that you provide should be consistent from endpoint to endpoint. The JSON format that you give out needs to be consistent from endpoint to endpoint. Things like that. And even here, if you look at the names of the variables, like this transform type is type here, it's type here, it's type here, and it's type here. So if one of these variable names was slightly different from the others, that would confuse the user. I mean, it's a very basic, simple thing, but like, I mean, it would compile and work just fine. But some simple thing like that would make it like unclear. Like you have to make it consistent like that. The next point is, this is a very interesting point, like it should follow the principle of least astonishment. As I say, so when you call something like this a transform method, it shouldn't maybe try to send an email to someone, maybe like try to even log the data. It shouldn't do that because the API doesn't show that it does. So say you had a need for this API to write this data into a file, what you would do is you would pass a service that could allow that in the constructor. Thereby, like looking at the API, the user would have said, yeah, it takes a file stream or something, so which I can use to write to a file. So because this doesn't, it says that it does everything in a very confined manner, in a constrained manner. So things like that. These are some of the general attributes of a good API. So if you take into other spaces like REST APIs, there are different patterns, there are different attributes, good attributes that those should have. For instance, like they should always be time bound, things like that, but I'm not going to touch on those. I think there are other sessions on like REST APIs. So that's pretty much it. It's quite simple here, and I just want to show this example. But as you can see, like the things I talked about, they're very simple things and simple things that you can do every day. Okay, thank you very much, everyone.